Good morning, students. Today we are going to deal with first law of thermodynamics. So first law of thermodynamics is called law of conservation of energy. You know what is meant by law of conservation of energy. Energy can neither be created nor be destroyed. It can only be transformed from one form to another. That is called law of conservation of energy. So first law of thermodynamics is based on that. So how can we define the first law? According to first law, if some heat is applied to a system, a part of that heat is used to expand the gas. Imagine a gas is enclosed in a vessel and there is a piston. So when the gas expands, the piston can move up. So what I am saying is, when I heat that container, the heat supplied is used for two processes or two parts. One part is used to do the work to expand the gas. So work done to expand the gas. The other part of the heat is used to increase the internal energy. So I say once more, the part of the heat energy is used to do the work for expanding the gas, and the second part is used to do the increase the internal energy. So I will be saying like this: the change in internal energy. So as per what I told you, delta Q is the heat supplied, delta U is the increase in internal energy, and delta W is the work done. So first law of thermodynamics can be written like this: delta Q is equal to delta U plus delta W. Okay, delta Q is equal to delta U plus delta W. That is what I told. Part of the heat is used to increase the internal energy, other part is used to do the work. So from here, what is delta U? Delta Q minus delta W. Am I correct? Okay. Now read this statement. According to first law, the change in the internal energy, that means delta U, of a closed system is equal to the amount of heat supplied to the system, that means delta Q, minus the amount of work done by the system on surroundings, that means delta W. So delta U is equal to delta Q minus delta W. Okay? Yes. So please write. So I have just written like this: delta Q is the heat supplied, delta W is the work done by the system, work done on the system by the surroundings. Okay, please correct it: work done on the system by the surroundings. And delta U is the change in internal energy of the system. So some part of heat supplied is get lost, and the remaining part is the work done on the surroundings. This remaining part is used up to increase or change in the internal energy of the system. Now I am mentioning about two cases here regarding the first law. So let us see one by one. In the case 1, imagine a system is undergoing a process such that delta U is equal to 0. There is no change in the internal energy. Imagine, think about a process like that. There is no change in the internal energy, which means internal energy of the system remains constant. Internal energy of the system remains constant. Now we are applying the first law of thermodynamics. Delta Q is equal to delta U plus delta W, and I already told you delta U is equal to 0 So I am putting delta U as 0, you will get delta Q equal to delta W. What does that mean? It means that the heat supplied by the surroundings is equal to work done by the system on the surroundings. So heat supplied is equal to the work done. I will give you the example. Just keep the gas in a movable piston and let the piston be very smooth, and I am supplying the heat. When I supply the heat, the gas is taking up this heat and the gas is expanding. The piston is going up and the gas is expanding. In that case, the entire heat is taken up by the gas, and that is only used for expanding. Until and unless this piston is completely expanded, the temperature of the gas is not going to rise. Suppose, imagine this much big cylinder it is, and I keep the piston here. When I start heating it, the piston will go up and up and up until it reaches the maximum. Till that, the gas will expand without an increase in the internal energy. And when the piston reaches the maximum height of the cylinder, then it cannot move further. At that time, the internal energy will start increasing. So till that, internal energy will remain same. Such kind of process is called isothermal process. So it is a process in which the temperature of the system remains same. Isothermal process. So here, so what I am saying is, when the internal energy is not changing, the heat supplied is only used to do the work. Temperature will not rise up. Change of state. See, for example, ice to water, that melting process. In the melting process, will there be change in the temperature? No. The heat that I am supplying is used to convert ice to water. So that is an example for this. Delta Q is equal to delta W. Now see case 2. System is a gas in a cylinder with a movable piston. By moving the piston, we can change the volume of the gas. And if we move the piston downward, some work is done and it can be given as delta W. So here what I am going to say is, here I applied the heat. In the first case, I applied the heat and just the piston moves upward. Now I am not giving up the heat, okay? I am not giving the heat. Instead, I just make it off and I am pushing the piston from top to bottom. When I push the piston, what happens? The gas will get compressed. And when the gas is compressed, some work is done on the gas. Isn't it? The gas is the system here, the cylinder, and the gas inside the cylinder is the system. When I push the piston downward, what will happen? I am doing the work on the gas. So the volume of gas decreases. The pressure of the gas will increase. Okay. So work done is delta W, and work is force into displacement. And force can be written as pressure into area. So pressure into area into displacement. Now what is area into displacement? Volume, delta V. Area into displacement can be given as delta V. So I will be writing delta W is equal to P into delta V. So work done will cause a change in the volume. Here when I am pressing the piston down, I increase the volume. I decrease the volume. Okay, when the piston is pushed downwards, the volume is decreased. That is why I wrote delta V. So delta W is equal to P into delta V. Therefore, the first law can be written like this. Instead of writing delta Q is equal to delta U plus delta W, we can rewrite this first equation as delta Q is equal to delta U plus P delta V. Okay, delta Q is equal to delta U plus P into delta V, where delta V is the change in volume. So, first law can be written either in this form or in this form. Okay. So, that is all about this. Thank you.